In this video, I'd like to continue talking about parallel and perpendicular lines by looking at their graphs. So in these example problems, we'll be given two different lines and need to figure out if they are parallel, perpendicular, or neither. And to do that, we basically just want to look at their slopes and compare them together. So remember that parallel lines, they continue in the same direction forever and they never cross. So these lines have the same slope. So if we can figure out that the slopes on these lines are the same, then we know they're parallel. And remember that slope is defined as how much the line rises divided by how much it runs. Or another way to put it, it's how much the y values change divided by how much the x values change. So we can figure that out if we know 2 points on the graph. And for perpendicular lines, it's a bit more complicated. So these lines, we can say their slopes are negative reciprocals of each other. So negative reciprocals. And a reciprocal, remember, is just a fraction flipped over. So if we know the slope of one of the lines, we write it as a fraction. If it's a whole number, we put it over 1. Then we flip that fraction and make it negative. So let's say we have two lines, y1 and y2, and we'll say they are perpendicular to each other. And let's say this has slope m1 and this has slope m2. Since we usually use m to define the slope, or at least in slope-intercept form, then the slopes are related by this fact here. The slope on line 1 will be the opposite of the reciprocal on line 2 of that slope. So it's a bit complicated. Another way to remember it is that if you multiply the two slopes together, this is equal to -1. And we'll look at the derivation of this, the proof of this, in a later video, but for now, we just want to get comfortable using this fact. And again, we just need two different points on each of our lines to determine the slope. So let's first look at this blue line here. And we know these 2 points, so we can figure out how much it rises and divide by how much it runs. So let's draw in a triangle to make it a little bit easier to see what we're looking at. So the rise, that's just how much the y values change. And it looks like they go up from this point to this one, 1, 2, 3, 4. Or really, we usually go left to right. So in general, when the slope is downward like this, it has negative slope. We would say the rise is negative. So we're going down 4 from this point to this point, just because we typically go left to right, or towards the right is the more positive numbers. So we go down 4 and then we count how much we go over. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So it looks like our run is positive 9. And if you don't want to count these out, you can also just find the difference in the x values. Since notice it goes from -6 to 3, so we can take 3 and subtract -6, or really it's just 3 plus 6, which is 9. So that works as well, and you could have done the same for the y values as well, taken 7 and subtracted 3. Or really it's vice versa, since we're starting here and ending here. So 3 minus 7 gives us a rise of -4. So we can say the slope on the blue line, and let's just call this m sub b, since we're talking about the blue line. So that slope is a rise of -4 and a run of +9. So the slope is -4/9. And let's do the same thing for the green line. We can again draw in a triangle, or we can just find the difference in the points. So this has an x value of 5, and this has an x value of -4. So it looks like its run, well, we go 4 to the y-axis and then 5 more, so that run would be 9. And it looks like its rise, we go down as we move to the right. and we're at positive 1, and we go down to negative 3. So that rise, it looks like, is also negative 4. Since we're going down, it's negative, and you can count 1, 2, 3, 4 units down. So in this case, the slope on this line, which we can call mg for the slope of the green line, so that is minus 4 for the rise and positive 9 for the run. And because the two slopes are the same, we know these are going to be parallel, since all parallel lines have the same slope. Now, if we got this relationship that when we multiply them together, we get negative 1, we would know they're perpendicular. And if we got something else that was neither the same slope or had this relationship, then we would know it would be neither.